Hey guys, welcome back. Hope you're doing well. Today I'm not really adding anything new. I'm just going to assign actual AP questions that have been used for free response questions in the past. And here's a little heads up, like what do you do for these weird looking things, okay? So I just drew these without any specifics so that we don't have to worry about the computation, just the setup, okay? So for the first one, I want you to write down and actually write it down what you think you would do to set up that problem, okay, to find the area. So go ahead and do what you think you should do on number 1. Hit pause. Okay, so the trick with this one, and this happens quite often on the AP exam, is you got to see that which curves you're using. In the beginning, you're using f of x and g of x to get this area, okay? Just trace and you can see f of x to g of x, f of x to g of x, f of x to g of x. But at some point, it changes. Right here, oops, that's crooked. Right there, now it's f of x and h of x, f of x to h of x. So the key is seeing that it changes right here at B. Okay, so you have to do 2 different integrals, one for the blue region and one for the red region. So that integral, to find the total area, we would integrate the blue part, f of x minus g of x, and that would go from 0 to B, whatever that is. And then for the red part, we would go from B to A, from B to A in that order, and now it's f of x minus h of x. Okay? So that's the thing, when there's more than one curve going on. Now, let's say you had to figure out on your own what these points of intersection are. For this one, what is that, an A? Yeah, for that one, you'd have to set f of x and h of x equal to each other and solve. For B, the one down here, you would set g of x and h of x equal to each other and solve. All right, so now do the same thing with option or number 2. Go ahead and set up your integral. Hopefully you understand better the point of this one, okay? Hit pause. Okay, how'd you do? We're going to integrate from 0 to B. The red region is f of x minus h of x. And then starting from B, going to A, the blue region is g of x minus h of x. Okay? Now try number 3, but I maybe have to clarify that this is the x-axis right here. So think of that x-axis as a line. Think of it as another equation, and its equation is just 0. Let's see if I hinted at it well enough for you. Give number 3 a shot. Okay, number 3, you can see that it switches right here at A. So we have 2 different regions again. We've got the blue region and then what I'll call the red region here. Okay, but if this doesn't have an equation, what is its equation? It's just 0. It's y equals 0. It's an equation. So to get the area of that blue region, hopefully you understood you're going to integrate from 0 to A. But what? You're going to integrate from top curve to bottom curve. So top curve is 0 minus bottom curve, which is f of x. So this is 0 minus f of x. Okay, think of that x-axis as an equation, and it's just 0, and you always subtract top to bottom. Now, clearly that 0 isn't really needed. You could just keep negative f of x, and you could even put the negative out in front of the integral if you wanted to. Okay, now the red region, similarly, would go from A to B, and it would be 0, top curve is 0, minus g of x. Okay, and again, you don't need those zeros. I just want to make the point that you always have 2 equations, even if it's the x-axis or a horizontal line. It could have been a line like y equals 1 or something. Maybe I had something like that, and then you'd go 1 minus f of x. Okay, even if it's a straight line, it's still an equation. All right, so hopefully that made sense to you. There's nothing really new today. Just going to practice some, we're just going to practice some AP questions. This is the first question, and it is an example of, this is just, this is your first problem, so I'm not going to do this all the way. But there's a line here. You can see there's a horizontal line. Well, what is that line? What y value is it going through? It's going through 6. This is y equals 6. And if you're having any trouble, just visualize connecting through that shaded region. We're trying to go from top curve to bottom curve. And so you have to subtract in that order, top minus bottom. and they're going to tell you what the equation of that curve is. Okay, and you're going to have to figure out where it stops so you can integrate from 0 to whatever this guy is, and that's the 9. So you end up using both the 6 and the 9, okay? So this would be integrating from 0 to 9, 6 minus whatever that curve is. I'll call it f of x. I don't know what it is because I'm not looking at the problem. All right, so I kind of sort of did that one for you. That's your first problem that you have on your homework. And some of them are calculated, some aren't. Make sure you pay attention to that, okay? And good luck. Hope you're doing well. Please remember, let me know if you need anything from me. Tell me if you have any questions or you want me to work out more problems, okay? You're not all alone, even though you are at home alone. Bye, guys. Hope you're doing well. Oops, I lied. I'm not done yet. One of the problems that you have to do by hand requires you to remember how to integrate these things. So I forgot that I added this to the end of the lesson. So these are all integrals you should already know how to do. I just wanted to do a quick reminder. Okay, and if ever you get something that looks confusing like this or this, then make up your own easier problem that looks just like it. Okay, when we integrate sine, you get negative cosine. So this is 2 negative cosine of 5x divided by the derivative of the inside, 5. Now, since this doesn't have bounds, you would have a plus c, but when you do it today, you're going to have bounds, so you won't need the plus c. Okay? So remember that. It's negative cosine, and don't forget, divided by the derivative of the inside. Okay, so number 2 is the same thing. It's negative 2 cosine of pi x divided by the derivative of the inside, which would be divided by pi. Then when you go plugging in numbers, they're going to have like 0 and 1 or whatever. Those pi's will work themselves out. You'll see it's not as bad as it looks. Okay? That brings me to the last one. This is going to be negative 2 cosine of, leave the inside the same, divided by the derivative of the inside. So we're going to divide by 1/2 pi. Now that 1/2, when you divide by 1/2, you're going to multiply by the reciprocal. And that's actually going to turn that into a 4 on top. And pi stays on the bottom. Okay? Now I'm done, I swear. Good luck. Hope you're doing well. Bye.